Hi, mathletes. Today, I want to make sure that you are refreshed on graphing. So remember, we need to find the zeros, end behavior, and additional points in order to sketch this out. Now, from here, we do want to point out that what we just reviewed was this idea of multiplicity. So very important. So I'm going to do this over on the side there. So we want to know what our zeros are, and we want to know what its multiplicity is. So the first one here, based off this right here, x, our first one is a 0. Why? Because when I use the zero product property, x is 0. And that only shows up once. Why? Because we have a power of 1 there. So let's look at the next one. Based on this expression right there, we have x minus 2 equals 0. So when I solve for that, x is 2. So the other 0 is a 2. But how many times does it show up? Dun, 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 dun. It shows up twice. So its multiplicity is dos. And the last one is based off this guy here. So when you use the zero product property, x plus 1 equals 0. So x equals negative 1. So negative 1 there, and the question is how many times does that one show up? Well, exponent is 1 there, so that's a 1. Why are these important? Well, let me show you. First off, we have our zeros, a 0, a 2, and a negative 1, so we can graph them over here. The 0 lives somewhere about here, our 2 lives somewhere about here, and our negative 1 lives there. Now, what we know, based on our theorem about multiplicity, we know that each one of these has a specific shape. This 0, at the 0, it is going to look linear temporarily. Well, this guy here is going to look parabolic because it's going to look quadratic because of the square. And lastly, this one is going to be also linear. Now, we don't know how sharp or steep or shallow it's going to be. Not yet. Not until we figure out how high and low it goes. All right, the next thing we want to find out is what is the end behavior. So when I take all these components, the x squared, and the x times x squared times x, notice I get x to the 4th power. As a result of that, we know that the end behavior is up, which means it starts somewhere up here and ends somewhere over here. And then it just does something inside there. And we're going to pay attention to its multiplicity, especially at this point at 2 there. So it's going to come down, come back up, and then it's going to look parabolic right there. So watch. I'm going to sketch it real quick. It's going to look linear right here. It's going to look linear here, and lastly, it's going to look parabolic here. So, last thing we need to do is figure out, well, what about how deep does it go, and how high does it go? So I need to find a nice little point that is in between here. So here's a negative 0.5, and here's a 1. So I'm going to find my additional points at those two junctures. So when x is negative 0.5, let's see what we get. I'm going to substitute things in. Negative 0.5, negative 0.5 minus 2 squared, and then negative 0.5 plus 1. Plug all that in my calculator, and I get negative 1.5625. So we're going to approximate that over here, and that's not going to get too low. So here's negative 1, so negative 1.5-ish is down there. So we're going to estimate it to be there. So we can actually make our little graph go down and come back up, and it's going to go straight like that. So again, multiplicity-wise, temporarily this looks like a straight line, that looks like a straight line, and over here is going to look parabolic. So the question is, how high does it go up here? So now I'm going to plug in a 1 to see what we get there. So we plug in, and we get a 2. All right, so that helps us out, which means this goes only to there. So when we finish this guy up, we got to loop it around like so. Then it's got to do a nice little somewhat parabolic, and then we just swing it up like so. And this guy here has just got to come up like so. And there we go. Now let's go ahead and check that using Desmos. So when I plug things in here, notice what we get. We do have our -1, our 0, and our 2 for our zeros. Notice that this guy has a minimum of about -1.62, which is approximately where we were. And then the next one here, this has a height of approximately 2, which is what we expected because at here is a 2. So good. Our graph works very much in line with what Desmos gets. All right, your job is to do this one. And let me point out to you here, because of this multiplicity, instead of having a linear or instead of having a parabolic, cubic looks like this. Cubic looks like that. So go ahead and attack, kill, destroy that one.